Yeah, good morning. Back with our classes on physics, that is electricity. We have to solve from question number 9. Okay, so the question number 9 states, a battery of 9 volt is connected in series with resistors 0.2, 0.3, 0.4, 0.5 and 12 ohms respectively. How much current would flow through the 12 ohm resistor? For this, a diagram is required because it is all about resistances and they are connected in what? Series. So, we will have, how many resistances are there? 1, 2, 3, 4 and 5. So, we will have 5 resistances connected in series. 1, 2, 3, 4 and 5. 5 resistances connected in series across a battery of 9 volts using a plug key. Okay, so the battery is 9 volts. Always put a positive and a negative sign in a battery. Then you have what all resistances? You have 0.2, 0.3, you have 0.4 and 0.5 and 12 ohm. This is how the resistors are connected in series. Okay, so the most important thing what we know is that in series circuit what remains same? Current remains same. So if I find the total current of the circuit, the same current will also pass through what? 12 ohm resistor. So first thing, we will calculate total resistance. Total resistance in the circuit. Total resistance is R1 plus R2 plus R3 plus R4 plus R5, which is 0.3 plus 0.4 plus 0.5. 4 only, no? 0.3 of 2 meter. 0.2 plus 0.3. 0.3, 0.2, 0.4, 0.5 plus 12 ohms. How much is it? 13. 13.4. 13.4 ohms. So total resistance is 13.4 ohms. I have a potential difference of how many volts? 9 volts. So we will use V is equal to IR. So V by R is equal to I, which is 9 by 13.4 is equal to I. So it is 90 by 134. Divide Madi 90 by 134. It will, I think, come up to 0.67 amperes. So, the current which flows through the circuit is 0.67 amperes. You will write this, please. You will write the total current flowing through the circuit is 0.67 amperes. The same current also flows through the 12 ohm resistor. As in series, current remains same. You have to write that statement, otherwise you will not get marks. So please write. The total current in the circuit is 0.67 amperes. The current passing through the 12 ohm resistor is also 0.67 ampere. As in series, same current flows through all the resistors. As in series, same current flows through all the resistors. Okay, now we will go to the 8th problem. Now we will go to the 8th problem. The 8th problem says, when a 12 volt battery is connected in series or connected to an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So first thing, V is given as how many volt? 12 volt. I is given as how many milliampere? 2.5 milliampere. We need to convert it into amperes. 2.5 milliamperes to be converted milli under 10 to the power minus 3. So you get what? 2.5 into 10 to the power minus 3 amperes. What I need to find out? R. So V is equal to IR. So V is 12. 2.5 into 10 to the power minus 3 into R. So 12 by 2.5. In the 120 by 25 into 10 to the power 3. 5 5s are 5 2s are 5 4s are 24 divided by 5 into 10 to the power 3. 4 point something. 4.8. So 4.8 into 10 to the power of 3 ohms. 4.8 into 10 to the power of 3 ohms. Now for the seventh problem. Seventh problem is right. It is a problem which has graph in it. The values of the current flowing in a given resistor, the corresponding values of potential difference across the resistors are given below. Plot a graph between V and I and calculate the resistance of the resistor. Idina manel madkodi. I will only calculate the R value. See what we will do. We will have I in amperes, or rather I in A, and we have what here? V in volts. Plot your graph between whatever values they have given. They have given 0.5. Sorry, I is given as 0.512. So you can start from 0, then 0.5, then 1, 1.5, and something like this. Okay. On the other side also you can start from 2. 2, 4, 2, 4, 6, 8, 10. You will always get a graph which is always parallel to the, which is passing through the origin. Straight line passing through the origin. Okay. We need to find out the resistance. So we will find out the resistance in one case, or in any of the case you can find out, because all ohmic resistance will have constant resistance. So let us take in one of them. Let us take in 4 and 13.2. So VI is how much? 4 I think, no? I is 4 amperes. Yeah. I is 4 ampere. V is 13.2 volts. So R is equal to, we have to find out. So V is equal to IR. 13.2 is equal to I is 4 into R. So 13.2 by 4 is equal to R. So how much will be the resistance? 3.4 3s are 12. 3.4 illa 4 4 is 16. Okay. 3.3 ohms. Correct, no? R will be 3.3 ohms. You can even take out in between one of them and try, but if you take 1 and 3.4, your value should come as 3.4. Isn't it? See the second one. If you take I and V, it will come as 3.4 by 1. So it is 3.4. Otherwise, all you see 1.6 by 0.5. So it is 16 by 5. 5 3s are 15. Then 3.2. So everything in a range of 3.2 to 3.4 you will get. Okay, you can do any one of them. Everything they will give you correct. Okay, so you can take this and write this as 3.3 ohms. Now for the sixth problem, leave space for the graph to be drawn. The graph will come something like this, straight line passing through the origin. Now for the sixth one, Please mark your numbers correctly as we are going ulta. Mark the sixth one or the sixth problem. Okay, it is a very nice problem which always has been asked. Mark it as important. A copper wire has a diameter of 0.5 mm. So diameter is given as 0.5 mm or 0.5 into 10 to the power of minus 3 meter. Next, it has a resistivity of 1.6 into 10 to the power of minus 8. So rho is 1.6 into 10 to the power of minus 8 ohm meter. Okay. Now, what will be the length of this wire to make its resistance 10 ohm? So we need to find out L. The resistance is given as what? 10 ohms. So the first part, let us find out length. What is the formula? R is equal to rho L by A. So what I need? RA by rho is equal to L. Correct? So what is R? 10. Area. Area is what? Pi r square. If I use the diameter, it becomes what? Pi d square by diameter by 2 is r. So it becomes pi d square. So it becomes pi d square by 4. So we will also substitute pi. Let us substitute it as 3.14 into ds2 0.5 into 0.5 into 10 to the power minus 3 into 10 to the power minus 3 by 4 because pi d square by 4 into 1.6 into 10 to the power minus 8. ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಪಾಸಿಟಿವ್ and solve. Yes, if you solve it finally, you will get the answer as 122.66 meter. This is the length of the wire. Kindly calculate it. Don't use a calculator. Use your simple multiplication and division. You will get your answer as 122.66 meter. The next part of the question, it says, how much does the resistance change if the diameter is doubled? Okay, see, we know resistance is inversely proportional to area, correct? If diameter is doubled, then resistance will become what? If diameter is half, resistance will become double, correct? If diameter is doubled, resistance will become radius is doubled because area is pi r square. I am making what? See, this is 1 by pi r square. This is proportional to r. Aita? Now radius na arda madidre resistance will become double. ಈಗ ನಾನು diameter na double ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಗಿ ಹೋಗುತ್ತೆ radius? 1 by 4. Sorry, resistance will become 1 by 4 because you take what? D by 2. D by 2 whole square. So this goes as 4. Understood? So please write. If the diameter is doubled, resistance becomes 1/4. Resistance becomes 1/4 as R is inversely proportional to A. As R is inversely proportional to A. Now to the next one. How is voltmeter connected in a circuit to measure the potential difference between two points. ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀವಿ voltmeter. We will first draw a circuit. We have a resistance and ammeter using a plug key. Voltmeter is always connected in parallel. Mark the wire joint, mark the current, positive and negative. Now write. Circuit draw madadmele baribekku. Voltmeter is always connected in parallel. Voltmeter is always connected in parallel as it is a device of what resistance? High resistance. Voltmeter is always connected in parallel as it is a device of high resistance. Are you sure it is time? Check once again. I think ammeter is connected in series. Correct, high resistance. Okay, now two conducting wires. This fourth problem is very important. Mark it as important. Two conducting wires of the same material of equal length and equal diameter are first connected in series and then in parallel across the same potential difference. The ratio of heat produced in series and parallel combinations. Okay, so first thing, as they are made up of the same material, the resistivity is same. They have equal length and equal diameter. So we need to calculate what first in series and then in parallel. So we have only what potential difference across the same potential difference. So V remains same. Heat produced. Which formula should I use? Same potential difference. V is same. Okay, R also is nearly the same because they have equal length, they have equal cross section and they are made up of same material. So R is same. Okay, now I need to calculate heat calculated in series and heat calculated in parallel. Which formula should I use? V square by R into T. So V square by R into T. Now please understand what it says. Two conducting wires of same material. So we have two resistances, isn't it? So in series, what is the resistance before this resistance? Two resistances. Connected in series. So you say R plus R. It becomes what? 2R. So heat produced in series V square T by 2R. Correct? Now two resistances connected in parallel. So it is 1 by R3 is equal to 1 by R plus 1 by R. So it becomes what? 2 by R. So R3 is equal to what? R by 2. Correct? So HP in series will be what? V square T by how much? R by 2. This 2 will go up now. So you will get what? HP is equal to 2V square T by R. Fine? Now what we have to find out? Ratio between series and parallel. So HS by HP. This is what? V square T by 2R, then 2V square T by R. Correct? So let us solve it. V square T by 2R into R by 2V square T. Correct? So V square T and V square T can get cancelled. This R and this R can get cancelled. So you will get what? 1 by 4. So HS by HP is what? 1 by 4. Fine? You can write, check your answer now. See, 1:4. But you need to solve all this. Without solving, you will not understand. ಇಲ್ಲಿ ಬರ್ಕೊಂಡು ಬಿಡಿ first. As the resistance are same, let it be R. It be resistance is same. Resistance is same, let it be R. Pause ಮಾಡಿಬಿಡೋಣ. Yeah, so this was our fourth problem. Now let us go to the third one. The third problem states, these are all problems which can also come, it is given as objective type, but it can come for 2 marks, 3 marks involved. So you need the solution. An electric bulb is rated at 220 volt and 100 watt. When it is operated at 110 volt, the power consumed by it will be. So first part, let us write what is given. It is, power is given as what? 100 watt. V is given as what? 220 volt. I will calculate what? I. So what I will do now? P is equal to VI. So 100 is equal to 220 into I. So 100 by 220 is equal to I. Cancel this. 2 5s are 2 1s are. So you get 5 by 11 ampere as I. Correct? Now the next part of the question. When it is operated on 110 volt, the power consumed will be. So now again we want power. It is operated at what volt? 110 volt. I is what? 5 by 11 ampere. I may be wrong or right. If I am wrong, you will catch me. Okay. So P is equal to again V into 5 by 11. So 11 ones are. So you get what? Power as 50. 50 watt. Answer is there already. 50 watt elladru. So please check. Now, where did I go wrong? You said 50 watts. Answer also we got 50 watt. But I went wrong somewhere. Where did I go wrong? This is how we will all do it. So that is why I am asking it. That's why before I started this part only I told I may be wrong or right. You have to catch where I went wrong.
We have to calculate current in seconds.
I have calculated current. Here the basic principle of Ohm's law is if V changes, I also should change. But am I not using the same I and calculating P? So this is wrong. The whole somehow I did is wrong. What should I do here? I should not use this formula. I should use what? P is equal to V square by R. Okay. So R is equal to what? V square by P, because R will remain same. So now 220 into 220 by what? 100. This and this will get cancelled. So I think 22 to 22, 484. So I get what? 484 ohms. You understood why this is wrong? Because if V changes, I also should change. Now what I have to do? So it is 220 into 220 by 484. Find out P.
110.
Sorry. 110 into 110 by 484. Divide ಮಾಡಿ. 2 2s are 4. 5 ಇಂದಾನು ಮಾಡ್ಬೋದಲ್ಲ ಇಂದ. 2s are 4, 2 4s are 8, 2 2s are 4. 2 5s are 10, 55. Then 2 1s are 2, 2s are 21. This is also 55. 55 into 55 ಎಷ್ಟು? ಮಾಡಿ divide ಮಾಡಿ.
3025. 55 55.
So 3025 by 121. Check the answer. Maybe 100 तो है नहीं, 75, 50, 50 भी नहीं है. So it is either 75 or 25. Divide.
25.
So your answer is what? 25 watts. Now you understood why it is not 50 watt, because if the voltage changes, what also changes? I also changes. What we were doing? We were using the same I. Now to the next problem. Which of the following terms do not represent electric power in a circuit? IR square. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. The equivalent resistance of this combination R dash, then the ratio of R to R dash is. Okay, so let us, I think we have done this kind of problems. If the ಮಾಡ್ಸಿದೀನಾ ಇದು?
Yes, ma'am.
ಮುಂಚೆ ಮಾಡ್ಸಿದೀನಾ? Answer ಏನು? 25. So we have done this kind of problem, and now Raghav, you said some question I left.
Page 213.
Page 213. So I have left page 213 in text question. So we will solve page 213 in text question. I think I left it by mistake. So we will finish it off. It says, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each. So we will put 3 cells, 1, 2, 3 cells of 2 volt each. So 2 plus 2 plus 2, 6 volts. Okay. Then it says what? A 5 ohm resistor, an 8 ohm resistor, a 12 ohm resistor, all connected in series. So we go back, right? 5 ohm, 8 ohm, 12 ohm, all connected in series across a plug key. 8 ohm and 12 ohm. Put an arrow, and this finishes your first question. Okay, redraw the current of question 1, putting an ammeter to measure the current in the resistors and a voltmeter to measure the potential difference across the 12 ohm resistor. So we will put across a 12 ohm resistor a potential difference or a voltmeter, and I need to connect what? An ammeter. So this is my ammeter, which is positive and negative. Voltmeter also, which is positive and negative. Okay, now it says what would be the readings in the ammeter and voltmeter. So let us find out first. We have 3 resistors of 8, 5 and 12. So total resistance in the circuit, it is 5 plus 8 plus 12. That is how much?
25.
25 ohms. Okay, V is given as what? 6 volt. So I will be what? V is equal to, we have to find out. So V is equal to IR. So V by R is equal to I. So V ಎಷ್ಟಿದೆ 6. R ಎಷ್ಟಿದೆ 25 is equal to I. 6 by 25 ಎಷ್ಟು? Divide ಮಾಡಿ. 0 point something.
0.24.
Adi ಬೇಗ ಮಾಡಿ.
0.24.
0.24. ಚೆಕ್ ಮಾಡ್ಬಿಡಿ ಒಂದ್ಸಲಿ. So you get ammeter reading as 0.24 amperes. Correct? This is what my ammeter reading is. What does it say? Find out the voltmeter reading. To find out voltmeter reading, I will use the formula V is equal to IR. I is 0.24, R is 12. So 0.24 into 12, which will be equal to 2.88 volt. 2.88 volt. Second time you will redraw the circuit with the potential difference and ammeter input and then calculate the current as well as the potential difference. So this finally finishes electricity. Tomorrow, one more day, we will do problems which are based on previous year's question papers. But I will start chemistry and do very slowly 2 or 3 problems every day. From exemplar book I have to do, and also I have to do from previous year's papers. Okay? So we will still probably next week continue with 1 or 2 problems of electricity every day. But officially this finishes your portions of electricity. It's a huge chapter. Please don't miss anything and solve all the questions. Particularly exercise questions are very, very, very important. Okay? So read through it, go through it. If you have doubts, you can call. Thank you.